Okay, so let's take this sample problem 8.1, wherein we have a mixture of gases that contains helium, it contains neon, so it has helium, it has neon, and it has an argon. And each of these individual components of your gas mixture has individual amount of moles. So let's write our given, or let's write that as our given. So first we have the number of moles of helium, which we are going to write as our NHE, and that is equals to 3.78 moles. And then we also have the number of moles for our neon, which is our N and E, that is equals to 1.36 moles. And lastly, we have the number of moles of argon, which is our NAR, then that is equals to 2.09 moles. So those are the individual moles of our individual gases in our gas mixture. Next, what the problem says is it determined the partial pressures for the gases or of the gases if the total pressure of the mixture is 4.25 atmosphere at a particular controlled temperature. So another given that we have is the total pressure of the gas, which we are going to write as our P total, and that is equals to 4.25 atmosphere. And lastly, what is asked of us is to find the partial pressure of each of these individual components of your gas mixture. That means is we have to find our PHE, our partial gas for NE, our partial gas for AR. So those are our asked. And in order for us to find this, the formula that we have to use is basically the formula that we just derived, wherein we found the relationship between our number of moles or our mole fraction with our partial pressure, wherein our partial pressure for any component is equals to their mole fraction multiplied by P total. So we're going to use that to find our or to solve our problem. So solution. The first thing that we want to do is to find our xi or our mole fractions. Find our mole fractions. And in order for us to find that, what we just have to do is take our individual number of moles, and then we just have to divide that to the total number of moles, which means we have to first find our N total. How much is our N total? We just have to add our NHE plus our NNE plus our NAR, and that is equals to 3.78 moles plus 1.36 moles plus 2.09 moles, and that is actually equivalent to 7.23 moles. That is our N total. Now we can now find, using these and the individual number of moles, we can find our mole fraction, beginning with the mole fraction for helium, and that was NHE divided by N total, which is 3.78 moles divided by 7.23 moles, and that is actually equivalent to 0.5228. And one thing about mole fractions is that they don't have any units, so this is already fine, 0.5228. Next, let's find our mole fraction for neon. Mole fraction for neon is the total number of moles of neon, which is our N and E divided by N total. That is equivalent to 1.36 moles divided by 7.23 moles, and that is actually equal to 0.5228. 1881 moles. Or no units, sorry, there's not mole in there. And lastly, let's find our XAR, which is NAR divided by N total, or that is 2.09 moles divided by 7.23 moles. And that is actually equivalent to 0.2891. So after finding that, what we have to do now is number 2, find our partial pressures. Partial pressure. So let's begin our PHE, that is equal to XE multiplied by the P total, or the mole fraction of XHE is 0.5228 multiplied by 4.25 atmosphere. And that is actually equivalent to 2.22 atmosphere. So that is the partial pressure of our PHE, or partial pressure for helium. Next, let's find the partial pressure for neon, or in our mole fraction for neon multiplied by the P total, or that is equal to 0.1881 multiplied by 4.25 atmosphere. And that is actually equivalent to 0.80 atmosphere. And lastly, let's find the partial pressure for AR, or argon. That is X mole fraction for argon multiplied by the P total, and that is actually equivalent to 0.2891 multiplied by 4.25 atmosphere, and that is equal to 1.23 atoms, or atmosphere, not atoms. So those are the partial pressure for our individual gases. And you can actually also find the P total, or no, which is, and you can check this if these are correct by adding them all up, and this should equal to the P total. So P total is equals to 4.25 atmosphere, and this should equal to the PHE plus PNE plus PAR. So if you add all of these, 2.22 plus 0.80 plus 1.23, and they equal to 4.25, it means you have your correct values for your partial pressure. So that is how you use the relationship between the number of moles and partial pressure, by first finding the mole fraction and use that mole fraction to find your partial pressures. I hope it's clear. If you guys have any question about this, do not hesitate to message me. Thank you so much, guys, and have a great day.